Hello and welcome. If you've ever felt like the term AI gets thrown around to describe, well, basically everything from your phone's camera to some future robot overlord, you are definitely not alone. So today, we're going to clear all that up. Let's grab our map and compass and start exploring the entire landscape of artificial intelligence.
Okay, so let's start with the big one, the most basic question of all. What even is artificial intelligence? Because, the answer that usually pops into our heads, the one from movies and sci-fi, is just one tiny little corner of a much, much bigger and more fascinating picture.
And that's really the key right there. AI isn't a single thing. It's not one destination you arrive at. It's this vast and varied landscape, right? It's got different territories from the familiar valleys we live in every day all the way to these towering, theoretical mountain peaks way off in the future. And today, we're going on a guided tour.
So, our first stop on this tour is a place you actually know incredibly well, even if you don't always think about it. Just think about your day so far. Chances are you've already used AI a dozen times without even realizing it.
This entire territory, the one we all live in, is dominated by something called narrow AI. Sometimes it's called weak AI, and the keywords here are single, specific, task. These AIs are total specialists. They are absolutely brilliant at doing one thing, whether that's recognizing your face or filtering out junk email, but they don't have any general intelligence, no consciousness. This is pretty much every single piece of AI you interact with today.
And just think about how common this stuff is. Asking Siri about the weather, Netflix giving you that movie recommendation that feels a little too perfect, your email inbox being magically, thankfully, free of junk, that is all narrow AI doing its job. They're incredibly powerful tools for sure, but each one has a very, very specific purpose.
But even inside this world of specialized AI, they don't all work the same way. The real difference, the thing that separates them, it all comes down to one absolutely crucial thing: memory. It's basically what separates a simple reflex from a more considered, intelligent action. So here we see this fundamental split. On one side, you have reactive machines. They live completely in the present moment. They have zero memory of the past. And on the other side, you've got limited memory AI, which, you guessed it, has a short-term memory. And that little bit of context, that ability to just peek back a few moments into the past, is what makes all the difference. It allows for way more sophisticated and adaptive behavior. Let me show you what I mean. All right, so the classic example of a reactive machine is IBM's Deep Blue. The computer that famously beat chess grandmaster Garry Kasparov back in the day? Now, Deep Blue wasn't remembering Kasparov's past games or learning his style. No way. It was just analyzing the board as it was in that exact moment, calculating millions of possible future moves, and picking the one with the highest probability of success. It was a pure, instantaneous reaction. A brilliant one, but still just a reaction.
Now let's contrast that with limited memory AI. A self-driving car is the perfect example here. To get you down the road safely, it can't just react to where another car is right this second. It has to remember where that car was a few seconds ago, right? It needs that to predict its path, to see where it's going, and to, avoid a crash. That short-term memory is the absolute critical difference between a simple reaction and an informed, context-aware decision.
Okay, so that's the AI of today. That's the land we're all familiar with. Now, let's leave this valley and start climbing toward those mountains we see on the horizon. This is the ambitious, far-off goal that really drives so much of AI research. And this is the quest for what we call artificial general intelligence, or AGI. Now, unlike those specialists we just talked about, AGI is the ultimate generalist. It wouldn't just be good at one thing. It could understand, learn, and apply its intelligence to any intellectual task a human can, from writing a beautiful poem to solving a complex physics problem. It would have genuine understanding and adaptability.
The leap from a specialist to a generalist it's monumental.
Think of it this way. Narrow AI is like a chess grandmaster who can only play chess. That's it. General AI would be a grandmaster of chess, and painting, and physics, and conversation, and it could probably invent a whole new game from scratch. Let's be clear, this is a goal that is still very, very far away. But what if we keep climbing? What happens if we go past that peak of human-level intelligence? What lies beyond that? Well, that brings us to the most speculative, the most mind-bending part of the entire AI landscape.
The philosopher Nick Bostrom gave this definition, and it's kind of chillingly precise. He describes an intellect that is much smarter than the best human brains in practically every field. And notice, he doesn't just say it's faster at math. He includes scientific creativity, general wisdom, and even social skills. It would surpass us in literally every way we can think of.
The potential here is just staggering to think about. An AI like this could, in theory, solve our biggest problems. Climate change, disease, poverty, you name it. It could create art and music that we can't even comprehend. But of course, it also raises these enormous, profound questions about control and about the future of humanity itself.
So we've toured the landscape of what AI is and what it could be. But how is any of this actually built? What's the engine that's driving this whole field forward? Well, that engine is machine learning, and it really comes in three main flavors. You've got learning by finding hidden patterns, that's called unsupervised learning, and learning by trial and error, like in a video game, which is called reinforcement learning. But we're going to focus on the big one, the most common one, the engine behind almost all the AI you use every day.
And that's supervised learning. I love this analogy for it. Think of it like teaching a toddler what a cat is. You don't sit down and write a bunch of rules for them, right? You just show them picture after picture, pointing and saying, cat, 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 and eventually their brain just figures it out. Supervised learning is that exact same idea, but on a massive scale with data.
So how does this actually work? Well, first, you start with a gigantic data set where you already know the right answers. Thousands of emails that are already marked spam or not spam. Then the AI model takes a guess on some new data. It's going to get some wrong, of course, but the key is this. It measures how wrong it was, it adjusts its own internal logic to be a little less wrong next time, and then it does that again, and again, and again, millions, sometimes billions of times, getting a tiny bit more accurate with every single pass.
And hey, if this list looks familiar, it absolutely should. Supervised learning is the engine that powers most of those narrow AI applications we talked about at the very beginning of our tour. From recognizing faces in your photos to predicting stock prices, it's all powered by this simple, powerful process of learning from labeled examples.
So, there you have it. We've journeyed from the AI that's literally in our pockets, all the way through the theoretical world of human-like intelligence, and even to a potential future that might be beyond our wildest imaginations. And we've even peeked under the hood to see how it all works, starting with simple, labeled data.
It really leaves you with one final, huge question. As we continue to build out this landscape, as we shape it and explore it, what's the actual destination we're trying to reach? What kind of intelligence are we hoping to create? That's the question that's going to define not just the future of AI, but our future as well. Thanks for exploring the landscape with me.